Hey, what's up YouTube? It's Joey Troy. Today we're going to be talking about AlpacaBridge and running our equipment with it. This is a piece of software that I've written, and we're going to go and dive in and basically I'm going to walk through and explain everything to you. We're going to set it up and install it, and we're going to talk all about AlpacaBridge. So if you want to know about ASCOM Alpaca and the future of astrophotography and EAA, stay tuned and let's keep going. Okay, so before we dive into all this, we need to talk about what is Alpaca and understand everything. So let's go back all the way to 1997. '97, Bob Denny creates ASCOM. It gets released in 1998 and is essentially the standard for controlling astrophotography equipment. We're talking about mounts. We're talking about filter wheels, electronic filter wheels. We're talking about electronic autofocusers. We're talking about cameras. We're talking about rotators, anything that's electronic that you can hook up to your telescope to essentially image the night skies, whether you're using doing it for astrophotography or doing it with EAA. And for those of you, EAA, it's electronic assisted astronomy. So that's basically the breakdown on how that all works. So Bob Denny and the ASCOM initiative essentially go out, they create the standard, and they specify how the standard works. Vendors release drivers for Windows. You install it on Windows, and you basically control your gear. Fast forward, I'm going to say in the 2000s, I can't remember exactly when, INDI comes out. INDI's all Linux-based. They don't like Windows. You know, can't blame them. But essentially, they create INDI. It's Linux-based, same thing. They set the standard for how devices work and essentially can image the night sky again with astrophotography or EAA. Shortly after, right around 2016, I believe, INDIGO comes out. INDIGO is another solution for, again, imaging the night skies, again, controlling your equipment, doing astrophotography or electronic assisted astronomy. And then in 2018, ASCOM releases Alpaca. What is Alpaca? Alpaca is essentially a solution that allows you to image the night sky just like INDI, just like INDIGO. The big difference is it's all designed to be network based. Also, it is also OS agnostic. So you can use it on Windows, you can use it on Linux, you can use it on Mac. So basically you have a control unit and you can basically talk to the device. What vendors are doing now is they're taking Alpaca and putting it directly into the equipment. One of the big manufacturers that's doing all that is Pegasus. They've introduced Alpaca into their mounts, and they've also introduced Alpaca into their focusers, which is really cool. Okay, so essentially what I'm doing is I'm taking Alpaca and using that API, and then with that API, I've created a web front end that you can connect to configure your drivers. All the drivers that I'm writing within Alpaca are based on the ASCOM standard. Essentially what I'm doing is going out to like ZWO's website, ToupTek, Player One, SV Bonnie, QHY, etc., downloading their SDKs, and then I'm using AI to essentially build the drivers. Once I get these drivers built, then I'm getting them all compiled and tested and verified with the ConformU tool that's being released by ASCOM. This tool is allowing me to essentially verify the drivers and make sure they work properly. So what I've done is I've taken this Alpaca API that was created by ASCOM and essentially pumping it in to Linux to run on like a Raspberry Pi. Here's a Raspberry Pi 3. This is, of course, the ASI Air, but if you pop off the cover inside, you've got essentially a Raspberry Pi. So essentially what I've done is I've taken Debian Linux, which is known as Trixie, and essentially set it up to run on Raspberry Pi. So it works on the ASI Air, which is a Raspberry Pi 3. Then you've got the ASI Air Pro, right? And this is a Raspberry Pi 4, and you can install it on here. I've got the ZWO ASI Air Plus. This is the Raspberry Pi version. It'll show it on the bottom of the device. It says RPI CM4. So it'll work on that. I recently just got my hands on a ToupTek StellaVita. It'll work on this too. I've got it all reloaded and set up with stock Debian Linux. We'll go through this video and I'll show you how to get it set up on the StellaVita. And I didn't forget you PC guys, you can run it on a NUC. I've got a little NUC Box 5. This is a little Intel chip. It's real low. I think it's like 4 gigs of RAM or something like that. It may have 8 gigs of RAM. I can't recall. But it's like a little Celeron that you can just install on and run it. All kinds of stuff over here. You could use like an SV Bonnie. This is the DC hub box. This isn't the Pro version. This is just like the real low end version. And then you can basically run these two together. So you have your power ports and everything, and you can essentially run it. What I like about the ASIRs and ToupTek is that they already have power ports plugged into the devices. And then essentially they have all their USB ports and their network cable. These are really nice because these are CM4s from Raspberry Pi, and they run a lot faster. So essentially I have instructions on how to install it on all of these. There's step-by-step guides in the wiki. And then I also have an installer that you can just install on here. You don't have to compile software. There's no crazy stuff like I had to do with previous versions. I also fixed this, I shouldn't say I fixed it, Raspberry Pi fixed it so you don't have to compile the kernel like I did way back when with the ASIR Raspberry Pi version, right? This isn't going to work on the newer rock chips that ASIR has released. I'm actually going to try to get my hands on one and see if I can get it to load up with Linux on there, but I haven't gotten there yet because I just spent my money on the ToupTek. So again, I'm buying all this hardware and testing it out. I'm also writing drivers for a bunch of stuff. So I've got the ToupTek camera here, and I'm working on drivers for this. I purchased a SV Bonnie, and I wrote drivers for that. So I'm slowly getting all these drivers built up so we can run it all onto a little Raspberry Pi. So it's got a lot of support for a lot of drivers. It doesn't have everything. If there's a piece of hardware that you want and you're willing to send it to me here in New Mexico, you can ship it to me. I can build the driver and ship it back, or you can watch my other video, which is down in the links, which will explain how to build the software with AI. I'm essentially using AI to do all this, but what's extremely important is I'm using the ASCOM Conform U tool to certify these drivers. So I'm not just, hey AI, build me a driver, and I just like, hey guys, here's the driver, you can use it. I'm spending hours beyond hours of debugging to making sure that the driver works properly. I'm testing it in Nina to make sure that I can actually use the driver. It passes all the Conform U tests, and all the drivers with all the Conform U tests are staying inside the repository so you can see them to show that I'm actually doing the work. I'm testing it both on ARM, which is your Raspberry Pi, right? I'm testing it on ARM platforms, and I'm also testing it on AMD 64 platforms for basically Intel and AMD processors. So I test it on both systems before I release it and do updates and stuff like that. So that's kind of the breakdown of the software, and that's kind of how it works. Real high level, but what we're going to do is install everything, and then I'm going to walk you through and show you what it looks like. So it's really slick. It's really easy to use. I have a telescope mount that I'll pull up behind me, and we'll go through the whole process. So let's dive into reloading the ToupTek and getting it set up. It's really easy to do. It doesn't take any work at all. So, okay, so I've got the ToupTek here. Let me just grab some quick tools. I just need an Allen wrench to open up the back. I'm using my iFixit toolkit. So, really like that toolkit. And I just need a bit. So essentially in here, we're just going to drop these 4 screws. And I've done this video before for the ASIR. It's the exact same process, but I figured we could just do it all here. So essentially the top lid's going to pop off, and then essentially you have the inside of the StellaVita. The next thing that we need is a paper clip, and in here at the top you'll see 2 pins. We just need to basically install it into those 2 pins like so. And then we need which I have next to me here. I have just a regular USB cable. You don't need anything special, just a USB A to USB C. We're just gonna pop it in here real quick. and then we're just going to plug it into our PC. Okay, we got the USB plugged in, so we're just going to choose AlpacaBridge Dev. This is a VMware box, so I've just got VMware running on a Windows workstation. So essentially it's all connected at this point. The next thing that we need to do is install RPI boot. So if you just type in Google and do an RPI boot installer, you can come in here and run the installer real quick. So on the page, just scroll down to the bottom or a little ways. For Debian or Ubuntu, you'll need to do the sudo app install lib USB, just copy it and then run it. I've already done this, so I don't need to. And then to build RPI boot, just click on this, paste it in here, hit enter, and then it's just going to download it and basically do the installation. It takes just a couple of moments, so we'll let it run through here real quick. All right, it's going to ask for a password. Type in our tippy top secret password in the window. There we go. And then it's going to load. It's going to connect to the RPI. It's going to do everything. So it's reading it. It's loading the bin files to basically boot it up so we can use it as a device. And it takes a second here to reboot. And then once it reboots and comes back up, it'll show up as basically like an SD card on Windows. But in this case, it'll be an SD card on Ubuntu. So it takes a second here. I just see like green lights over here on my side. All right, it's going to try to connect the device. So again, we're going to connect it to our VM, and then it'll pop up here. And then in a second, we're going to see some drives come up. There we go. There's our boot and roots. So at this point, we need to back up the device before we wipe it, right? If you want to use StellaVita in the future, you need to back this up. So to back it up, just go to a new tab. You're going to need to install PV. V as in Victor, not something else that may sound like something else, but so you can just do a sudo app install and then PV, and then hit enter, put in your password, it'll install it. I've already got PV installed, so we're good. The next thing that I'm going to do in here is type in disk. On the disk, I'm going to see that there's my StellaVita, which is the 31 gig drive. So basically it's the device that we're going to back up is dev/SD SDB, which is the full system. So so in here, we're just going to type in PV -EE capital EE space /dev/SDB. And you're going to use whatever yours is. Like when you plug it in, it could be like what SDB. Yeah, SDB. It could be like SDC or SDA or who knows what it's going to show up as. Whatever it is, use that. We're going to use our little alligator symbol. And then we're going to go in, type in ToupTek .img. G is in go. And then hit enter. Oh, sorry, you have to write sudo. You have to run this as sudo. Sorry, my bad. So essentially it lit up the green light on here. So it's trying to copy in, or not trying, it's basically backing up bit by bit. And essentially it'll create an IMG file. So it'll run through and we'll let it finish and do its thing. It takes about 30 minutes. Since I've already done this, I don't have to, so I can just do a Control-C, cancel it. So we're good. So essentially once it's backed up, it'll say it's completed and stuff, and then you're good to go. You'll have a backup image. I'd recommend backing that image up somewhere so you can have it, so you can restore it at a later time if you need to restore it. The next thing that we need to do is we need to download Raspberry Pi Imager. So we're just going to do a search for RPI Imager or IP image, doesn't matter. And then in here, it's going to take you to the Raspberry website. You're going to go ahead and download Linux version of the app image. Once it's downloaded, you can't run it through the browser, so you just actually have to run it from the download area. Type in our password. Once it comes up, we're going to choose Raspberry Pi 4. I'm going to hit next because we have the compute module, right? That's what's inside the StellaVita. It's a compute module 4. So we'll hit next. You can opt to install the full desktop if you want. I don't recommend it. We don't need the desktop. There's no reason to ever install the desktop. Everything we're doing is web-based. So I go to the Raspberry Pi OS Other, And then essentially I choose the 64-bit with no desktop environment for Debbie and Trixie. Hit next. We're going to choose the storage device. We're going to hit next. In here, you'll put in your host name. I'm just going to do dev. Again, this is just a dev box, but you can call it whatever you want. In here, you're going to choose your capital. I live in the United States, so Washington, D.C. is mine, but there's tons of capitals you can choose. Hit next. Your username and your password. Again, this is a dev box, so it's all dev, dev, dev. You can set up the Wi-Fi. So if you want to use the Wi-Fi that's built into it, there's like a little adapter you can screw in and stuff to get like a little extra coverage. You can use that. That's up to you. I actually opt for, oh, it's, where is it? I don't even know where it's at. It's around here somewhere. It's got a Wi-Fi access point. I don't know where the heck I put it. It's like behind me somewhere. But I've got a little Wi-Fi access point that I use, so I don't configure the Wi-Fi on here. But if you want to set up your own Wi-Fi network so you can connect to it, like from your laptop, you can put in your own network and stuff like that. You'll want to turn on SSH by default. It's on, so leave it on. You can use the Raspberry Pi Connect if you've got your Raspberry Pi hooked up, you know, StellaVita, ASIR, whatever you want to put in that name, or if you just have like a regular Raspberry Pi, you can hook it up to your network, and then you can basically connect to it if you want with the Raspberry Pi Connect. It's pretty slick. Maybe it's useful if you had like you're at a remote observatory and you need to connect to it. That might be a way to do it. I haven't used it in that sense, like where I've got a remote observatory set up where I can control all this yet. I usually just take all my gear with me and go image. So once you're done here, you're just going to hit write, and then it's going to essentially write the disk. Once it's done writing, you'll understand, and then it's going to write it. So I'm going to pause the video here. All right, we're all set. We've got basically the StellaVita's all has been written to, so it's set up to go. So we'll just hit finish. And at this point, I'm going to go ahead and disconnect the USB and then disconnect the paperclip. And then we're going to go ahead and put it all back together again. And then I'm going to hook it up over here. I've got a Jackery and a network cable. And then we're going to use Windows and then get everything set up so we can basically finish the installation on here and get everything going so we can use it with AlpacaBridge. Anyways, in here in MOBA Xterm, you just want to go to Tools and Network Scanner. We're going to scan the network, and there's the dev. We're going to connect to it, type in our dev username, accept, and we should be into the server, and we are. So there we go. Let me just shrink this window a little bit and make this one just a little bigger. Okay. In here, we want to go to GitHub, OpenAstro, and then under OpenAstro, we are going to go to AlpacaBridge. And then under AlpacaBridge, we're going to go to the wiki. In the wiki, I have installation on how to install for a NUC. So I got so much stuff on my desk. So if you got a NUC, you install on a NUC. If you got a Raspberry Pi, so if you got a 3, 4, or 5, that'll work. If you've got the StellaVita, which we've got right here, God, it's so weird. It's the camera's backwards when I'm looking at it. Sorry, guys. So StellaVita's right here. So if you got the plus right here, again, it needs to, on the bottom of it, it needs to say RPI CM4. Also, if you've got the ASIR Pro, which is the old school one with the SD card that goes up here. So in here, we'll click on ToupTek. It'll have everything in here. I've got the video, which will be linking maybe to this video, probably to this video, probably would make sense. I've got a picture of like where you have to plug in the pins. But if you scroll down a little bit, there's a section where it talks about doing the update for the RPI. So you just highlight it. You can just copy it. And then you can use your center click button over here inside MOBA Xterm. Click it, enter, and then it's going to basically go through and do the update. So I'm going to let it do its update. Once it's done, it usually takes about 5 minutes. I'll be right back. It just got done doing the reboot, so we're back up. I didn't show you last time, but when I logged in, it was kernel version 40 something, and now it's on 75. The next thing we need to do is the USB fix. The USB fix is essentially we're going to install the Renaissance firmware. This is the exact same firmware that you have to use on a ZWO. So ToupTek and ZWO use the same controller, I guess. So paste it in there, hit enter. It's going to install it. Bring that down just a little bit. And then we have to rebuild the init. RAM FS, and then basically it does a reboot. So all it's doing is it's taking the firmware that we just downloaded and it's integrating it into the kernel so that when it reboots, the kernel will work and the USB ports will work. Well, the firmware works. Well, there's still one more thing that we have to do to get everything working. So I'll just be a second here. So I'll go ahead and just pause it again. Okay, we're back up. And essentially now what we have to do is we have to modify the boot config. And essentially we're going to turn on GPIO pins. It's the same thing that we've done with the ZWO for a really long time. This time there's a total of 6 pins that we have to turn on. So there's 4 pins that control the power ports here. And then there's 2 pins that control the power for the USB ports. So I figured that all out doing some debugging on the device after I got it reloaded and stuff after I backed it up. So in here, I've got all the pins listed. So if you only want certain pins to be turned on for like power, you can opt to modify this. So the pins are 18, 10, 17, and 4 to control the pins, and it shows like the port number. So you can modify like which port numbers you want. So like if you only want port 1 on or port 2 on, that's cool. If you don't care and you just want all the ports turned on, you can just turn on all the ports. So again, we'll just copy this. Got to copy this so we can modify the config file with nano. So you're going to use your arrow key to go all the way down. And then in here, you'll copy the pins and then paste it and then hit it and then hit Control X and then yes or Y, just hit the letter Y, and then it'll accept the config. And then we're just going to do a sudo reboot now. And then essentially when it reboots, you'll, shoot, I unplugged the power. I guess that'll reboot it. Okay, so I accidentally pulled the power. So when it boots up, now you should see the power ports as you can see them there. So all 4 power ports are powered up now. So we know they're working. So essentially that's good to go. So it wrote, at least I wrote the config, I just didn't reboot it. So at this point, we're good to go. We're ready to install basically AlpacaBridge. So we just got to wait for the unit to boot back up so I can log into it. So let me just, there we go. So to load AlpacaBridge, it's super easy. You don't have to compile any software or anything like that. I'm releasing Debian files for both the NUCs and then also the Raspberry Pi. So in your browser, you just want to go to apt.openastro.net. It'll take you to the apt package repository. In here, you just scroll down and there's a couple commands you got to run. So just highlight these commands and then paste them, hit enter. Whoop. And then it's going to install the keys. Let me just shrink this window a little bit there. I don't know why it keeps doing that. Next, you'll do the repository source, so you can link to the repository source of OpenAstro. So just copy that and paste, enter. In here, you can copy and paste this. I'm just going to do one command at a time so you can kind of see how it goes. So essentially, you just do a sudo app update. It's going to update your repository. And if you look in here, it's got the repository for OpenAstro. It knows we're on an ARM platform. So if we did this on like a NUC, which is like an Intel platform, it would say AMD 64. So it automatically can check it checks basically against the app repository, knows which platform architecture you're using. So to install it, you just highlight it and hit enter. And it'll download the package and install it. And then once it's done installing, you're good to go. So at this point, I'm going to go ahead and shut it down. I'm going to get it hooked up to the mount behind me, and then I'll show you the equipment that I've got on the mount, and then we'll configure AlpacaBridge, and then we'll use Nina, and we'll start rocking and rolling here. Okay, so what we've got here is a Red Cat 51. We've got our Wi-Fi access point that's hooked up. We've got the StellaVita. We've got the ASI or the ZWO electronic autofocuser. We've got the ASI 120, and then we've got a 2600 MC. And then there's a filter drawer over here, right here. If I could just point at it, that would be awesome. So that's essentially our hardware setup. We're going to swing back over to the workstation and then do some more testing. Okay, so we got AlpacaBridge all installed. I've got everything hooked up on the mount now, per that video I just showed you. So essentially in here, we're just going to go to Tools, Network Scanner. It should pick up, I'm on the .8 network now because I'm hooked up directly to my Wi-Fi access point. So I'm going to scan. There's our Alpaca, and all we care about is we just wanted to know the IP address. So it's 8.123. So we'll go ahead and close that out and then just open up this browser window a little larger. So we'll go to 192.168. Sorry, the keyboard was on something. 68.8.123.6800. So welcome to AlpacaBridge. This is essentially just a web server that you can communicate to work with the device. There's not a whole lot to it. It's very simplistic. I wanted to keep it that way so you don't have to like learn a whole nother tool. So there's a server info tab. In here, if you want to, you can specify your city, state, provenance, and country. That's the way it's configured per Alpaca. As you can see, we're running Alpaca version 1.0.0. There'll be some new updates coming out here shortly that you can install, so you can get it all the way up to version 1.0.1. And then I'm going to have another version .2 coming out shortly after that with more drivers. So once you put in the city, state, and county or country, you can save it and put in your information. If you need to do logging or something's wrong or something's coming up like it's not working right, do a log, send it. You can basically turn on the logs all the way to trace if you want. You can check mark this so it does unlimited storage, and then basically run whatever you're running, and then you can download the logs. Once you download it, it creates it into like a text file and stuff, and you can send it or post it like if you have an issue. So if you go back to OpenAstro, and then in here you want to go to AlpacaBridge, and then if you have an issue, you can just go to the issues and basically post your issue. As you can see, these are not issues. These are all adding new capability and new stuff. So I'm working on all this hardware. It's not there yet, but it's coming really soon. And then I'll be adding hopefully more as the weeks and days come. So in here, you could do a new issue and basically just attach your log file, and then I could go through the logs and figure out what's going on. But so far, I haven't seen any issues whatsoever, knock on wood, but it works phenomenally well. Because again, all our drivers are Conform U certified. They're certified. They passed all the tests. They work amazing. So again, that's what makes this solution so freaking awesome. So in here, we'll just turn all that stuff off. In here is the configure tab. This is super easy. You just do a drop down and choose your equipment that you want to install and install it. Some of these things don't have stuff. So like if you go to Dome, there's no vendor. I don't have a driver yet for the Dome. But in here, you can go to like Telescope. You can select your vendor, Ioptron. You can come in here and put in your IP address. I think it's 225 and my port is 8890. And let me just make sure that's the right IP address. We can check real quick. I was wrong. The IP address is .180. So 180. That must be the IP address for my HAE 29. So in here, you put in the IP address, the port information. You can put in all this extra stuff if you want for the aperture, diameter, area, and focal length. I haven't worked with Nina yet, but I'm hoping to work with them so that when you put this stuff in here, it'll automatically get input into Nina, like when you go into the settings and stuff like that. Again, I haven't worked with them on this, so this feature doesn't work quite yet. So just hit Add Device. It'll add it. You got your telescope. Next, you go back. We choose a camera. We choose ZWO. Again, not all the cameras are in here yet. I'm still working on all the drivers. And then you can hit Add Device. And then in here, it'll show you your camera. So it's got the 120 that it sees. So we'll go back in, add another camera. We'll choose ZWO. You'll notice that the camera index changed. So every single camera that you add or every single device, if you have multiple of the same devices, which You shouldn't, except maybe cameras. It'll just go from 0 to 1, and then 1 to 2, 2 to 3, so forth and so on. So we'll add this. So in here now we have the 2600 MC Pro. So in here we're going to go to configure, and then we're going to choose focuser, and then in here I've got ZWO and Gemini. That's that Gemini focuser, that really cheap one. I watched Quiv. He released a video on it, and I was like, hey man, that thing's super cheap. We should buy it and write drivers for it. So I bought it and wrote drivers for it, so you don't have to download from that stupid Facebook group. You can just install AlpacaBridge and get it to work. So go in there, or I'm sorry, ZWO, and then add the device, and then essentially add the focuser. So we've got the focuser, the camera, and everything's good to go. The one thing we need is the dew heater. So in Alpaca, you can't like flip on the dew heater like you normally can with like the ASCOM driver. You actually have to add it as a switch. So if you come in here and go down to switch, and then you're going to choose ZWO. Now you have to specify the camera index. So if you remember earlier when we did the camera index was 0 for the ASI 120, and now the camera index for the ZWO 2600 is 1. So we set the camera index to 1 and hit add device. So we'll go back and see that. So in here, I've got everything just so it like squeezes down. So if you click on details, it'll show you everything. So in here, if you click on the details, we can see that the camera device ID is 1 and the camera index is 1. So in here, the dew heater that's associated with the camera also needs to be showing the camera index is 1. And again, every time that you add a device, the very first device that you add will always be 0. So don't freak out that the dew heater is 0, but the device number for the camera is 1. All we care about is the index. And all this is telling us is that the camera index 1 is associated with the camera 1. So everything will work just fine. So that's all our hardware. So everything's good to go. So at this point, I'm going to go ahead and open up Nina now. And you can just minimize this. You don't ever, like once you get all your devices set up, they're set up. Every time you shut down your Raspberry Pi or your NUC and reboot it, everything's going to be there. All the settings stay. The only time you'll ever need to go back into the AlpacaBridge is to essentially add new hardware as you add new hardware. So if you get a new filter wheel or you get a new, whatever device you get, come in here and add it. So in here, I'll just minimize this because we don't need the web browser anymore, and we'll fire up Nina. I've already configured Nina before, so I'm just going to use my test profile. Essentially, it'll connect in and show all my devices. But essentially, what you do is it already shows the device. But when you start brand new and fresh, like I'll just hit refresh, and it won't show anything in here, or it still ties to it. It'll show the cameras that you have. So if you don't see something, you just hit the refresh button. It'll refresh. It'll scan the network. So as long as you're on the same network, this computer is connected through Wi-Fi to the mount, I can see everything that's being basically presented through Alpaca. So Alpaca communicates on port 11111, and basically Nina says, hey, is there anybody out there? Is there a camera out there? And then basically all the stuff that we configured in that web portal is saying like, hey, I've got a camera. So again, it's showing our 120 and our 2600 in here. So we'll turn it on. It turns on, turned off the fan. So the cooling's off. You don't see the success symbol, but it's way down in the corner over here. So you can turn on the cooling. So you can turn it on and the cooler turn back on. And then you'll start seeing the camera. Let me just move my picture here. You'll start seeing the camera cooling, and then you'll start seeing the temperature drop down. So it's instantaneous. Again, it's just like ASCOM, except this is ASCOM Alpaca. So instead of being plugged in directly to the mount and connecting to it, we're basically communicating to the Raspberry Pi, which has got all the devices plugged into it, and it's basically sending out all that information through HTTP. So it's really cool. So next up is our focuser. We'll turn it on. Focuser's on. It shows exactly where it's at, and then we can move the focuser and stuff. So we can do like an autofocus. I would take this outside, but it is clouds galore, so that's not going to work. We'll go to the mount. We'll connect to our mount. We'll connect to it, and then it'll sync from the mount. If I had like a GPS that was plugged into this computer, I could get my GPS coordinates and pull them in, so it was completely accurate. and then essentially I could sync from Nina to the mount. If the mount is completely accurate, I could go from mount to Nina. So we'll just go from Nina to the mount, and basically it connects to it. So in here, you can see the mount behind me. So I'll just move it. So it's moving, as you can see back there. Then I can like go north. And don't worry, I'm not going to hit that tool. It's like way in the corner of the room. It's an optical conclusion, as my father says. So essentially, the mount's moving. As you can see, everything's good to go. So we can just hit the home button, and I'll send it home. In here, you can go to the guider. To install the guider, you'll need to download a special version of PhD2 that I wrote. So in here, you just want to go back to OpenAstro, and then in here, you'll download PhD2 Alpaca. And then in here, you'll click on releases. I have several releases that I've released so far. This has nothing to do with PhD2. I forked their project and I customized it. And it's only at version 1.2.0. I basically have removed all their drivers and taken everything out of it, all the bloat. And it's just using just Alpaca. So if you don't have an Alpaca device that's supported right now with the driver set, it will not work. Again, I'm adding more drivers. I'm going to be releasing more drivers so you can basically support more stuff. But out of the gate, it's only working right now with ZWO. Once I release my next few updates, it'll have SB Vani, ToupTek, and then I've got Player One coming. ZWO, QHY should work. So there's quite a few guide cameras that are working. I'm also working on a new guiding software that I'm going to release as well, but I have to wait until my Player One camera comes. So I will be posting more information about that in the coming weeks. I've got the software all developed. I just don't have a camera to test it because you need a camera that has super fast frames per second. So these traditional cameras like ZWO, we're talking like 14, 15, 16 frames. I'm actually using a Player One guide camera that does 136 frames per second. So it's going to really, I'm hoping to achieve amazing guiding, but again, stay tuned, more to come. So anyways, download it, install it. I've already got it all installed and everything like that. So in here, once you've got PhD2 configured and installed, it's still just like normal PhD2. The difference is it's all Alpaca. So just turn it on and connect. It'll connect to it. And then I've got PhD2 right here. Let me just let's just go through the config real quick. So we'll go in here and go to let me just turn off everything. So disconnect, and let me just delete the profile, and we'll start over. So in here, we'll go to turn it on, and it'll start the wizard. So in here, the wizard pops up. You'll choose your guide camera as Alpaca. In here, you'll discover the server, and then it's going to find the server, which is right behind me. So it found the server at 123. It found the 120 camera. It's also got the 2600 listed there. So we'll do that, hit OK. It'll automatically sync to the camera, pull the driver, and figure out the pixels. So you don't have to worry about the pixel length in here. You just have to set the focal length. And because that's an OAG, it's 250 because it's sitting on the red cap. We'll hit next. Next, we'll choose the mount. Hit next. In here, if you have a rotator, I've got support and drivers for the ZWO CAA only right now. So if I have the CAA rotator on here, I could choose that, but I don't have the rotator installed on this particular equipment. So next, and then we'll just call it test, hit finish, and then it'll build the dark library. So the dark library will come up. So in here, you'll set your minimal exposure. Usually when I'm guiding with the Ioptron always recommends 0.5. So I usually just do 0.5 to like 0.1.5. So like when I'm guiding, if I have to increase because stars are not that great, I'll do a longer exposure, but usually I'm okay with 0.5. So we'll just start. The guide scope's already covered, so we're good. So it's just going to go through and basically capture all the images. And again, this is all connecting through the network. So it's the network's just talking to the camera over there and pulling in the images over here onto the Windows computer. So this would be the same thing that you would do at a dark sky site and configure everything and go. So It's all good to go. So it's all built. Everything's ready. So if we were outside, I could start guiding if I wanted to. But again, we're indoors. So, and I don't have a guide star inside. So I'll minimize that. The switch is the last thing. So we'll turn that on for the dew heater. Again, like I said, you have to make sure that the dew heater is associated with the camera ID, like I showed earlier. So in here, on here, I know I already said it once, but just to make sure we're on the same page, the camera ID is 1 and the dew heater is associated with camera ID 1. So the dew heater, you just flip it on and it turns on, and then essentially it'll start using the dew heater on the camera. So, all right, guys, so that's the end of the video. Essentially, that gives you a breakdown of how to use basically AlpacaBridge with Nina and connect to it. I hope it was helpful. I hope you guys start using the software. I'm really excited about it. Again, I can't stress it enough. I think what makes this software so amazing is it's ConformU certified. I'm not about to poo-poo on any vendors or anything like that, but I would recommend, it's in your best interest to plug in your devices that you have with ASCOM, download the ConformU tool, and test it and see how it runs. And you might be surprised at how bad it might be too. So with that, I appreciate your time, and you have yourself a good one, and we'll catch you in the next one.